This is the demonstration of the Requs AI software from FMEA. It picks up where the Requs AI edge case prediction left off. Recall that the edge case prediction takes our states and our interfaces and it generates specific root causes that are related to our traffic light. In this particular example, root causes related to the state management, to the error handling, and it populates them so that we can see exactly what the edge cases are. Three of the most critical ones that we saw is that we could have a prohibited transition. The light might turn from red to yellow, from green to red, or from yellow to green. This is software controlled. That is definitely possible. So let's look at our effects now. Let's go to the TLS root causes here. Those are the easiest probably to analyze. We'll start with those. So let's look at the first one. That let's assume the transition from red to yellow has been allowed. We don't second guess how this happened. We'll get to the root cause shortly. We assume it has happened. The light has changed from red to yellow. All right. And the root cause there could be many things, such as it could be faulty logic. There could be, well, really faulty logic is one way it could happen. There's all kinds of things that could go wrong with variables. The fact is, it has happened, it can happen. It's software. So if the light turns from red to yellow, we're definitely going to have some confusion. Probable traffic stalls. People won't know whether to go or to not go. Possible collision, depending on what people choose to do when the light does this. So we're definitely going to have erratic behavior as our mission effect. Company effect, they're probably going to get complaints. And then on the end user, their immediate effect is that is largely they don't know whether to go or stop. Or go. Safety effect is possible. Probably more than likely is that nobody will do anything, but possible. So let's save these effects. Let's go back to our hazards. We have collision is H1, traffic stalls H2. We know it could really cause any one of those. So let's pick the worst case scenario here. Let's go ahead and pick, let's see, where was I? We will pick H1 for the worst case scenario. You can see it set our severity to 1. Now let's pick a different one where the light transitions from green to red. This one is more obvious what the effect would be. We're going to have a collision. Cars will be in intersection when light turns. It's green instead of being ready for it to happen. So let's see, there could be lawsuits that could happen because of the lights. Well, actually, let's put that over here. The mission effect is mission affected by collision, obviously. And on the end user, we're going to have people in intersection when light turns. They may not even know that it has changed. They may not even know that the light has changed because it's above it. Okay, is this a safety effect? Yes, for sure. And for sure, this is an H1. So you can see there, the different transitions have different effects. Now, the transition from yellow to green, again, that's going to cause more confusion. The goal of the Requs AI software for FMEA is that these root causes and local effects that are in the first 5 columns Those are the hardest, that's where all the work is. So the software does the heavy lifting. It generates these root causes specific to my traffic light. It tells me which ones are applicable, which ones aren't. All I have to do is connect the dots, which you can see took us under a minute to connect 2 of these dots. Connecting the dots between the root cause and the effect took less than a couple of minutes to do. So that's what the software FMEA does. That's the bulk of it. The next thing it does is the likelihood. And this is the other part of the software FMEA that is exhaustive and drains resources and is often done incorrectly. Okay, the traditional methods for likelihood for hardware do not work for software. There's many other packages out there that use hardware-centric approaches. They do not work. For software, we're not going to assess some number like 10 to the minus 6, etc. With software, this is a design FMEA. Does it exist or not? That is what we're looking for. So the existence likelihood is assessed based on past history and whether or not this failure mode is clearly insufficient, whether or not there's any criteria that it will exist. Manifestation is whether this particular root cause is single point or multiple point. Many of the root causes in our list are single point failure. The state transitions, for example, are single point failures. Control likelihood is whether or not we have any preventive controls that will keep this failure mode from happening. So in the case of our prohibited transitions, some controls could be continuous monitoring to ensure that those prohibited light changes don't happen. And then the detection likelihood is whether or not we have a specific test case for this root cause. Are we testing the prohibited state transitions? When people test, they tend to test the allowed states. They almost never test the disallowed states. So the likelihood is assessed based on the questions that we answered over here in the survey tab. And we can override them. Here we have to justify if we do. And we should also list any existing controls. So for example, if we do have continuous monitoring for invalid light changes, for example, then we could reduce our control, our control override. Instead of being 5, which is guaranteed, we could reduce it down to say 1 if it's a good control, and that would reduce the risk. All right, and then we could justify why we reduced the control. So the likelihood part, we're really just taking a look at what Requs predicted, making some adjustments based on controls that we might already have in place. Now, we don't change the likelihood if the control is not in place yet. We'll talk about that shortly under mitigations. So let's look at mitigations. Now, when we get to the mitigations part, each root cause, let's go to the state management root cause to show our example. Each root cause has a recommended, let's go backwards, has a recommended corrective action. It has a recommended fix, a recommended control if there is one, and a recommended test procedure. General testing, just requirements testing, will not detect any of these root causes. If it did, we wouldn't need to do this analysis. So here we have some recommendations. The FMEA team needs to have a multifunctional team, decide on what they think the recommendations are, and present them to the software group.